Dear audience and followers, hello and welcome back in this new video tutorial with this topic using a 50 Hz device on a 60 Hz supply system and vice versa. So here we're going to discuss the effect of using different rated devices of 50 Hz or 60 Hz on different systems like 50 or 60 Hz systems. Actually, when it comes to the frequency issue, the world is divided almost into two systems. One is the 50 Hz or 50 cycles per second power supply system or power system, which is found in most of the regions of the world, like in Europe, most of Asia, Africa. And the other system is the 60 Hertz or 60 cycle per second, which is more dominant in North America and some parts of Asia and South America. Some of the devices produced might be rated 60 Hz, some might be rated 50 Hz. So the question arises, can we use them interchangeably with the two available systems? The short answer is yes, and sometimes the short answer will be no, but sometimes this can be yes also. So it's a bit controversial, but we'll discuss into more details the consequences of this interchange. So the various effects can range from negligible to potentially destructive if we use a 60 Hz device on a 50 Hz system, depending on the specific device and its design. So it depends. We'll see this into more details, but generally using a 50 Hz device on a 60 Hz supply might be problematic, but also depends on the specific device and its design. Let's see how. In this, we'll just have a breakdown of the potential impacts, but will not, for the time being, will not go into the mathematical and technical details behind this. Maybe in a subsequent video, we'll discuss the technical details. So part one, how does using a 60 Hz device on a 50 Hz supply, how does this affect it? Like imagine if you're buying a device and some electrical device like a microwave, like a refrigerator, a washing machine, a deep fryer from the US and coming into Europe or some Arabic or African country, and you want to operate this machine. So the potential positive effect would be is that no impact. So some devices are designed to operate on a wide range of frequencies, like it can simply operate between 50 to 60 Hertz, which is very common nowadays, okay? And hence it will function normally on 50 Hertz supply without any noticeable difference. But this is not always the case. Now we want to study the case when there is a difference. Okay. So one of the differences would be, or the potential negative impacts would be the reduced performance. Like motors designed for 60 Hz might run slower, or actually they will run slower, okay? And they'll be slow by some 20%. Those who are interested, maybe in a subsequent video, will just tell you why and prove it mathematically why 20%. So the RPM or the speed of the motor would be 20% slower, like if the RPM designed is 2000 RPM, it will generate or operate with an RPM of 1600 if used on this machine or this motor if used on a 50 Hertz system. Another issue or potential negative effect might be overheating. So like devices with transformers, like in the power circuits or even inductors, might experience increased core losses in the magnetic core due to higher magnetic flux density at 50 Hertz, and this might lead to overheating and potential damage. Again, I'll discuss this issue for those who are interested into more details with some equations and mathematical elaboration in a subsequent video. Another issue might be related to timing, like incorrect timing or operation. And this we can encounter if we have some devices relying on precise timing, like clocks, timers, counters, and like this. They will display some inaccurate results or malfunction due to the different cycle rates. Again, mathematical issues I'll discuss later, but you'll expect some malfunctioning or some wrong or inaccurate results. Actually, I want to just summarize this for you. Now, when it comes to loads, mainly we have resistive loads and inductive loads, okay? When it comes to circuits, we'll mainly have these electronic circuits like clocks, timers, like counters. But if we talk about resistive loads, the effect would not be that high or noticeable, except of some flickering effect. Like you might notice some flickering effect for the 50 Hertz system. This might not be that much noticeable, but it will be there'll be a difference in flickering actually, but this would not be an issue actually. But then we have the problem with motors, and we have the transformers or inductors circuits. Usually in transformers and motors, we'll have two issues of speed issue, and we'll have also the problem of heating or electrical losses, because still the motors have something similar to what the transformers have, and that is the core and the windings, okay? Then what other potential problems might be? Lifespan reduction. So the increased stress from operating at the different frequencies can shorten the lifespan of the device. So it might work actually, okay, even with the problems that we mentioned. It will operate for some time, but the lifespan would decrease. Like if it's designed to work for 5 years, maybe within 2 or 3 years it will start failing. Another issue or another potential negative effect might be the safety risks. So in extreme cases, the device wasn't designed for 50 Hertz operation. It might overheat, malfunction, or even pose a safety risk due to component failures. So this is the most extreme case, is to cause some safety risk. What recommendations we have is to avoid using 50 Hz devices on 60 Hz devices on 50 Hz supply systems, unless the device explicitly states compatibility with both frequencies and you understand the potential risk and limitations, and it's for short-term and non-critical use. Now, part 2 is the opposite. Using a 50 Hz device on a 60 Hz supply system, like if you're buying some device or machine from Europe and going to the States or some other part where they have a 60 Hz supply system. So again, the same logic applies. Like we might have no effect or some potential positive effects that the device would operate normally, because it's already designed to work within the normal range between 50 and 60. Okay, but this is not the issue that we want to discuss now. We want to discuss the potential negative effects. So for motors like increased speed, so motors might those motors designed for 50 Hz will run faster, on 20% faster. This is the opposite. Like again, if it's designed to run or operate on 2000 RPM, so you'll expect it to run faster and have an RPM of 2400. And this would lead to increased power output. This could be beneficial in some applications, apparently, okay, but might even overload the motor if not designed for it, because this speed design is something crucial, and usually you will face such an issue. Consequently, there will be an expected increase in wear and tear, because faster operation can shorten the lifespan of the motor, especially the shaft and bearing problems we expect because of the increase in speed. Safety concerns: in extreme cases, high speed could create vibrations and other safety hazards, so maybe even these parts might tear apart. One more problem is the reduced torque. So the increase in speed might come at the cost of reduced torque, affecting the performance. So if it's designed to start with some certain type of load, maybe the motor would not be able to start with the designed optimum load. Overheating, again the same problem as we have seen before. So similar to 60 Hz devices on 50 Hz systems, transformers and inductors might experience increased core losses due to higher magnetic flux density at 60 Hz, leading to overheating and potential damage. Again, the same issue of incorrect timing or counting with the timers, with counters, with clocks. So we might have an issue of synchronization. We'll lose synchronization. We'll have false readings for timers, for clocks, for counters. And the recommendations is to proceed with caution. Like while 50 Hz devices on 60 Hz might be less risky. So now using 50 Hz devices on a 60 Hz system might be less risky than the other way. Like, I mean, it's more risky to bring some machine from USA operating or designed to operate on a 60 Hz system and operated at a 50 Hz system, but the opposite is less risky. I mean, you can, with less risk, take devices of 50 Hz and operate them in the US. I want to remind you, like now in the US, in some places, you might have the dual system, 50 and 60. And you have to assess the potential risk and consider the points mentioned above and the specific devices you are using or device you are using. And start with a short-term use. If needed, try the device for a short duration or short period of time and assess if there is any sign of overheating or abnormal behavior. Monitor the performance if there is some change in speed, noise, vibration, or heat generation. So, in conclusion, remember that using incompatible devices can have unwanted or undesired consequences, potentially leading to damage, malfunctions, or even safety hazards. When in doubt, prioritize safety and seek potential advice before using a device on an untested power supply. So this was just a simple introduction for those of non-technical or little technical background or little technical information. Okay. In a subsequent video, I'll discuss some technical justifications and logic behind everything discussed in this video. And if you have some specific comments or questions, please leave in the comments so that I'll include in my discussion in that video. Thank you for being attentive. I hope this video was informative and of help to you. For similar material, please subscribe to my YouTube channel, share and leave your comments. Thank you again and see you in the next video. Goodbye.